Okay, I will go over your practice 5B test. Your actual test will be an exact copy, or at least the type of problems you'll have on your 5B test will be exactly like the problems you had on the practice test. So follow the video here and you should be able to do well. Okay, so let's see here. The first problem, we had -3 times the square root of -25, and so we find the largest perfect square factor of 75, and it's 25, so I can write 75 as 25 times 3, the square root of 25 times the square root of 3. 25 times 3 is 75, and then times the square root of -1. The square root of 25 is 5, and then the square root of -1 is I, and then we multiply -3 times 5i, we get -15i root 3. Next one, we have 2 times the square root of -45. Again, we find the largest perfect square factor of 45, and that's 9. And 9 times 5 is 45. And then we have the square root of -1. Oops, come on. Notification, move. Ugh. And now, so the square root of 9 is 3. And the square root of -1 is I. And so we have 2 times 3i, which is 6i, so 6i root 5. And again, I think I noticed somebody was using plus or minus with these. We're not solving for x squared. We're just evaluating a radical. Okay, so we don't have a plus or minus. We're just simplifying radicals here. We're not solving. Next one, again, 32 is, break that up into the largest perfect square factor of 32 is 16. 16 times 2 is 32, and then times the square root of -1. And then we have the square root of 16 is 4. And then the square root of -1 is I. So we just have 4i root 2. Now this is where we're actually solving for x squared. We'll get plus or minus here. In the other ones, we were just simplifying a radical. So we have 3x squared plus 54 is equal to 0. Subtract 54, we get 3x squared equals -54. Divided by 3, we get x squared is equal to -18. And now you take the square root of both sides, and you get x is equal to plus or minus the square root of -18. Again, the largest perfect square factor of 18 is 9. 9 times 2 is 18, and then times -1, the square root of -1. Square root of 9 is 3, and the square root of -1 is I. So here, plus or minus 3i. Notice we have plus or minus for solving for x squared. Okay, the next one here, so complete the square. X squared minus 4x plus 28, we set that equal to 0. We get the c term on the right, so we have to subtract 28. Now we have x squared minus 4x equals -28. We complete the square. We take -4. We divide it by 2. And so we get, and then we take -2 times -2, and that gives us 4. So we're completing the square. Again, we had our x squared minus 4x, and there's my x squared minus 4x. Again, we take that b term, -4, divided by 2. We get -2. So the sides of our square are x minus 2 times x minus 2. But when we complete the square, we add it 4. Okay, so we add 4 to both sides. Well, x minus 4x plus 4 is a perfect square trinomial whose sides, as you can clearly see in the square, are x minus 2 times x minus 2, or x minus 2 squared equals -24. Take the square root of both sides. You get x minus 2 equals plus or minus the square root of -24, and the largest perfect square factor for 24 is 4. 4 times 6 is 24 times the square root of -1. The square root of 4 is 2, and the square root of -1 is I. So we have plus or minus 2i root 6, and then we add 2 to both sides. Our final answer, 2 plus or minus 2i root 6. Here we're solving for x, so we subtract 24. Divide by 2, we get x squared equals negative 12. Take the square root, you get x is equal to plus or minus the square root of negative 12. Largest perfect square number or factor of 12 is 4, so 4 times 3 is 12. So the square root of 4 times the square root of 3 times the square root of negative 1. And the square root of 4 is 2, and the square root of negative 1 is I. So we have plus or minus 2i root 3. The next one, again, this is a complete the square problem. So we have 0 equals x squared plus 10x plus 37. We subtract 37. We want the a and the b term on one side when we complete the square. We take that 10, we divide it by 2, we get 5. So our square sides will be x plus 5, x plus 5. And then we take that 5 and we square it, so we get 25, so that's what we add to both sides. So x squared plus 10x plus 25, that's a perfect square trinomial whose sides are x plus 5 times x plus 5. Negative 37 plus 25 is equal to negative 12. Square root both sides, and you get x plus 5 equals plus or minus the square root of negative 12. The largest perfect square factor for 12 is 4. 4 times 3 is 12, so the square root of 4 times the square root of 3 times the square root of negative 1. And then the square root of 4 is 2, and the square root of negative 1 is I. So we have x plus 5 equals plus or minus 2i root 3. Subtract the 5. X is equal to negative 5 plus or minus 2i root 3. Okay, so here, a little difficult to complete the square on this one. Why? Because, well, that b term is not even. So I'll just go ahead and then use a quadratic formula. A equals 1, b equals 7, and c is equal to 4. So x equals negative b plus or minus the square root of 7 squared minus 4 times a times c. 7 squared is 49, and negative 4 times 4 is 16. So we have 49 minus 16 is 33. And so we have final answer, negative 7 plus or minus the square root of 33 over 2. The next one, again, this would be difficult to complete the square, so just use a quadratic formula. A is 3, b is 4, and c is 3. And we plug it into the quadratic. X is equal to negative 4 plus or minus 4 squared minus 4 times a times c, or 3 times 3. All over 2 times 3. So 4 squared is 16, and negative 4 times 3 is negative 12, times 3 is negative 36, so 16 minus 36 gives you negative 20. So we have negative 4 plus or minus square root of negative 20 over 6. Square root of negative 20 is equal to 4 times 5, the square root of 4 times the square root of 5 times the square root of minus 1, which is just 2i root 5. So now we have negative 4 plus or minus 2i root 5 over 6. I can simplify out of 4, 2, and 6. I can simplify that. I can divide those three numbers by 2. So again, negative 2 plus or minus I root 5 over 3. Okay, the next one again involves a quadratic formula. Wait a minute, did I just do that? No. So it involves a quadratic formula again. A is equal to 1, b is equal to 7, c is 15. So I have negative 7 plus or minus 7 squared minus 4 times a times c. So 49 minus 60, which is negative 11. So negative 7 plus or minus the square root of negative 11 over 2. And then that simplifies to negative 7 plus or minus I root 11 over 2. Here this is add and subtract, so we have 3 plus negative 2 is 1, and 5 plus a negative 6 gives me negative I. So negative I. 5i minus 6i. This one here we change subtraction to addition, so we distribute the negative. So we'll have plus negative 18. Okay, negative times a negative is a positive, plus 9i. We add 6 plus negative 18, that's negative 12. And then we add 17 plus 9i, and that's 26i. Number 13, we multiply. We distribute the 3i, so 3i times 6 is 18i, and then 3i times 7i is 21i squared. And remember, I squared is equal to negative 1. So we have 18i plus 21 times negative 1, or negative 21 plus 18i. And we always write that in a plus bi form. Real part first, imaginary part second. Do that on your test. Make sure you write it in complex number form. Otherwise, you will lose a point or half a point. Okay, next one. So 5i times 3 is 15i, and then 5i times negative 4i is negative 20i squared. And so we have 15i minus 20 times negative 1. That's 20 plus 15i. In here we FOIL. So 3 times 6 is 18. 3 times 6 is 18. 3 times negative 2i is negative 6i. Negative 4 times 6 is negative 24i. And then negative 4 times negative 2i. Negative 4i times negative 2i is a positive 8i squared. But I squared is equal to negative 1. And so we have 18 minus 8, which is 10. And then minus 30i. Negative 6i minus 24i is negative 30i. Again, the next one, so 2 times 2 is 4. We FOIL. 2 times positive 4i is 8i. Negative 4 times 2i is negative 8i. And then negative 4i times positive 4i is negative 16i squared. And so the 8i minus 8i, that just goes to 0. So we have 4 minus 16 times negative 1, which is 20. Negative 16 times negative 1 is 16, and 4 plus 16 is 20. And then with these here, we graph. So we graph the function x squared minus 6x plus 8. And then we graph the line y is equal to 3. Okay, so the line y is equal to 3. And we want to know when that graph, that parabola, is above y is equal to 3. Okay, so as you can clearly see, okay, so that parabola, that yellow line, or the red line highlighted in yellow, is above y is equal to 3, that green line, from 5 to infinity, and then from 1 to negative infinity. From 1 to negative infinity. And then let's see here. And now again, we graph the equation, negative 2x squared plus 3x plus 7. It's a sad graph, and then we graph the equation y is equal to 2, and we want to know when that line, when that parabola, that blue line highlighted in yellow, is above the line y is equal to 2, greater than or equal to 2, okay? And that's the case here for any values between negative 1 and 2.5. The y value for that parabola is greater than or equal to the line y is equal to 2. So from negative 1 to 2.5, will be the solution. And here, the number and type of real solution. So remember the discriminant is b squared minus 4ac. Here the evaluates is 0, so we just have a perfect square trinomial. In fact, I could factor 4x squared minus 28x plus 49, and that factors 2x minus 7 times 2x minus 7. So I only really have one 0, and that's 7 halves. So it's a perfect square trinomial. So one real solution. The next one, 3x squared minus 8x plus 8, use the discriminant, and we get negative 32. We have two non-real solutions, imaginary roots. No real solutions. Complex numbers. Imaginary roots. And then the last one here, we get, for our discriminant, 55.61, so it's positive. So we have two real solutions. That parabola, that quadratic somewhere, is going to cross the x-axis in two places. All right, so that's it for your practice test. Your actual test will be very similar. Same type of problems, just change the numbers.